Hello, and welcome to today's class. Good morning once again. So, today I want us to recap on SQL, which is going to form a basis of most of the things that you're going to do into, or rather, inside our database. So I'll jump straight into it. We're going to discuss SQL, and SQL is basically structured query language, and it is the programming language that we're going to use within our database for purposes of creating objects, fetching data, deleting data, updating data, generating reports, and things like that. So there's really quite a lot that you're going to do with SQL. In addition, it is going to form the basis for other elements that you're going to create within our tables. For example, things like stored procedures, functions, events, and so forth and so forth. So those are the things that we are going to uh, do, but we will need to understand how SQL works first of all, so that we are able to work with them efficiently. So for today, I will want to focus on SQL as a language. So I'll just create a few elements here and there, then we'll be able to see how we can be able to interact with them with this language. So um, if I go back, well, I just wanted to confirm that the recording is actually good. So that's fine. So I'll open SQL Yog. You can feel free to use any MySQL GUI. I'm going to use standard and C SQL statements, so that shouldn't be a big deal. So let me just change this view a bit in terms of growing the font. Let me see options where user interface. Well, I think the statements should be visible from here if I'm since I'm recording here in high definition. So to begin with, that's how we put comments in SQL. So I'll put a comment here as we continue. SQL is divided into three parts. The first part is what we call DDL, or data definition language. So these ones are responsible for creating, managing, and deleting database elements or objects. So with DML, or rather with DDL, we are going to be, they are the statements that are going to be responsible to allow us to create different things. So I want to create a sample database here. I'll just call it movies. I don't think I have movies. Well, probably I think, yeah, I don't have movies database here, so that's fine. So to create a database, actually they're classified into three. We have what we call uh, create, then we also have alter, then you also have things like drop. Occasionally, you have things like backup for database. There are those special ones that apply to other components, but we're not going to focus on that for now. We're going to look at these first three. So create. So let's first of all create a movies database using SQL. So to create a movies database, I'll simply say create your database, then just give the database name movies. Then you put a semicolon. Now, most of the SQL statements are going to end up with a semicolon. So once you have that, simply click on this play button or execute all queries. If I highlight a statement here and I click on execute, it will only execute this particular statement. But if I click on execute all, if I had multiple queries over here, it will be able to execute those multiple queries. So I'm creating my movies database and I'll simply say uh, uh, play. So when I do that, you're going to see down here, it tells me it's successful and has created a movies database. I don't know if I can be able to see it here yet. Maybe if not, I can simply click on this refresh icon, then come back down here. I should be able to see my movies database created here. It's empty with nothing. So that's actually good because we were interested in creating the database. If I wanted to drop the database, I'll simply say drop database movies, execute that, it will drop the database movies. If I refresh this, you're going to see that the movies database is actually should actually let me just refresh this. You should see the movies database is no longer there. So let me just create it back so you can be able to use it. So I have created my movies database. Now I have it, even though I'm not seeing it here, I have it because if I said use movies like that, then if you switch up here, you're going to see it has now moved to movies. So in as much as I'm not seeing it in the object browser, but if I refresh, I should be able to see it. But it is actually within my list of databases. So let's move on to the next element. So that is we have talked about create. Let's look at how we can be able to use something like alter. So okay, actually before I go to alter, let me first of all create a table called say titles of movies. So I can simply say create object name, which is a table. I want to call the table movies or movie titles. Then I put an open bracket. So down here, what you're going to do is you're going to be inputting you're going to input the column and the data type. So for now, we are focused on the column and the data type. So here I can have movie. First of all, I have movie ID, which is integer. Put a comma. I have movie title. Let me just say title. Let me say movie title. Then that is variable character 50. Then let me talk about director, variable character 50. Let's talk about release here. That is going to be integer because it's a year. Then let's talk about rating. That's going to be decimal. Maybe I want um, 5 characters and 2 decimal points. Then I have something like synopsis. That's variable character 50. I can have something like date added. That is going to be date. You can put date, date or time, or time. Then I can have a status. Um, and for status, let me just say movie status. That is going to be variable character 50. Um, yeah, and I think I can have a deleted. I'll simply say this is boolean or bool, and I can go on and on. So technically, what I'm trying to say is when you want to create a table, you simply say create table, then you say the name of the table, then you open a bracket, then you put your title, your data type, title, data type, and then you continue on until you've put uh, all your all your columns. So here, uh, this is basically my movies database. And again, when I say use movies, it's going to switch which database to use because I might want to use a different database from the one that I'm currently accessing. So when I say use database name, it allows me to be able to use that kind of database. So when I highlight this and I click on play, you can see it is telling me it's successful. So when I come to my tables, I find I have my movies table, and of course I have all the columns as I have stated. Now, why is this important? Because sometimes when we are writing our queries, we'll be able to generate a few items here and there. So it's very, very important for us to be able to know how to do that. Now, so that is create. So let's look at how we can alter this database because these are going to be very important statements that we're going to use over and over again. So to alter this database, let me say, for example, this movie status I've said it's variable character, but I want it to be able to only allow me to have either it is released, it was cancelled, or it is upcoming. So what I could do is I want to add a status here. So let me just explain what I mean. So if I come to my table and I come and say movie ID, actually let me alter this with the GUI and make it a primary key. Well, I can do that with code. I just don't have the time or the luxury for that. But let me assume I have that. I have the movie title, maybe The Pelican Reef by Donald Magnum. This is fictitious. This This was released in say 2010, and the rating is maybe 5.2, and the synopsis is a trial of an army soldier, blah blah blah. Date released, maybe say I can click on date here, and because I'm talking about 2010, I can come here and say 2010, maybe it was January 5th. Okay. Then the movie status. Now, when it comes to movie status here, you can say I can just put anything. I can say okay, right? Then deleted here, I can put something like deleted is zero, which means it's active. So you can see it's accepting okay. But I know the movie status should not be okay. It should either be released or upcoming or cancelled. Those are the three options I would want to have for my type of movie. Either it should be released, upcoming, or cancelled, and no other value other than that. So I'll cut that and I'll set that to null for now so that we can be able to come and modify it later. So because I want to control what can be put here, I will add a check constraint. So I can come and say alter table. Then I give the table name, it is movie titles. Then I'll simply come and say add. We have different types of constraints. We have primary key constraints, we have check constraints, we have foreign key constraints, we have indexed constraints, and so forth and so forth. So the constraint I want to add here is actually what we call a check constraint. Okay. So to add a check constraint, I'll simply say add check. Then I'll now put the check constraint inside a bracket. So I want to check the movie status, which is the column. Then I want to check that it is either either of the three values. So here I'll use the in statement like that. We're going to learn how to use the in statement. Then I'll put the values that I want. I want it to be uh, upcoming or released or cancelled, like that. Okay. So if I do that, then it will mean either of these three are the only ones that are going to be allowed. By the way, if you don't want to use in, you can simply say uh, though that's the easiest, but yeah, that's the easiest. Let me just use that because you can use an or statement here. So you can say movie status is equals to upcoming, or movie status equals to risk, or movie status equals to cancel. But this is a nicer way of doing it because now I can add more values without referencing the column name several times. So I think I like that option better. So I'll run that. You can see it's successful. So when I come back to my movies table over here and I try to say here okay, and I try to add, you can see it tells me it's not allowed because I cannot be able to add that. I cannot be able to put that particular value as okay. But if I put something like upcoming, it is going to accept that. If I say released, it's going to accept that. And if I misspell release, you can see it does not allow me to do that. So that's why we add check constraints. So when you want to add check constraints, you can say alter, then the table, then you specify the table, then you add a check constraint, you specify the column and the values you want for that column. It could be you're comparing numbers where the movie's status is greater than 5 or less than 15. Whatever it is that you want to add as a check constraint, you can be able to add it here. It doesn't have to be either of the following three values. It can be anything. Maybe it can be a number, maybe it can be a pattern. You can even use a regular expression for all I care. It will all depend on actually how you want to go about it. So that is how we will be able to alter the table, and of course how we can be able to carry on with the other elements. Now if say for example I had forgotten a column up here, I want to add the column, I'll still use the alter table. Then I'll specify the table name. It's movies database, movie titles rather. Then let's add a column added by. Okay, so I'll simply say add. Then for the columns, you don't need to say add a column. Of course, you can say add column. Column. Is it column now? Uh, yeah, you can say add a column, but of course, I'm trying to use standard SQL, which means the statements that I'm writing here should work more or less in any database, not necessarily MySQL alone. So again, there's some syntaxes that when you use, they might be a bit of a problem in some other RDBMSs, but I'm trying to make it as standard as possible so that wherever you write, whichever database you write it in, whichever RDBMS database you write it in, it should be able to work out just fine. So I'll say alter database add. So I want to add added by. So I'll simply say added by. Then I'll simply say added by should be integer, right? So of course I can put a comma and add another column and add them and on and on until I'm done. So when I run that, execute one, you can see it is successful. So when I come back to my table, I should be able to see added by down here. So this is what we are referring to as DML. Of course, you can also use a drop statement to be able to remove um, some elements from your database. So let me say create a table called users. So create table users. Then maybe for users, I want to add two columns, user ID is int. I can make it a primary key. Of course, I don't want to do that for now. For now, I don't want to make it very, very complicated. Just straightforward structure that you can be able to understand easily. But of course, once you get this, you can add other things like primary keys, foreign keys, unique keys without necessarily adding them later. But of course, you can still add them and alter as you move along. So user ID, then I want username is variable character 50. Then of course we have maybe first name variable character 50 and maybe last name variable character 50. So let me assume that is my users table. So I can highlight like that, click on this execute. If I click execute all, it will run all the queries inside this window. So you don't do that. So if you want to execute only a portion of the query, highlight, then you click on execute one, not execute all. Okay. So that creates my table. And if I come back to this, refresh this list, I should be able to see now I have users. So if I wanted to delete that table users, I simply say drop table. So you say drop, then the object you want to drop, then you put the name of the object like that. So when I run that, it will be successful. And of course, when I click, you see now the users table has disappeared. So that is DML, or that's DDL rather, or data definition language. So as I said before, it is responsible for helping us in creating, managing, or of course modifying and even deleting database objects. And objects are things like the database itself, their tables, their indexes, their columns, and so forth and so forth. So it will depend on what you are looking at. So that's a primer of what the DDL is, or data definition language is. So now we are not going to focus more on DDL, but it's good to know how to work with it so that whenever you want to create objects on the fly, maybe things like backups or things like that, you can be able to do that right inside your statements without using the graphical user interface. So now let's look at something else called DML, and this is where we're going to focus on 95% of our time. So D so I've just right click on this and said new query. So let's talk about data. The second category is data manipulation language. So this is DML, and this is the language that allows you to interact with allows you to interact with data inside your database. We're going to look at quite a bit of it. So first of all, we'll start with fetching data. So, well, before we start with fetching data, let me start by adding data because I don't have any data as yet. So let's start with adding data so that we can now be able to manipulate that data after we have added it. So let's add a few movie titles here and there. So what I could do here is to add data, you're going to use the insert statement. So the insert statement looks like this. So you'll say insert, then you specify the table name. Here you can just double click, the table name comes here. Then you open bracket and you input the values, rather the columns. Now movie ID is auto increment, so we ignore it. So I'll start with the movie title, comma, director, comma, release date, comma, rating, comma, synopsis, comma, date added, comma, movie status, comma. maybe deleted by default is 0, and of course added by, we can also specify. So you just double click on the columns, they'll come on this side. Now, not all MySQL graphical user interfaces are going to allow you to do that. I'm just doing this because it makes it easier, so I don't have to type everything else. Don't worry about the backticks because they are basically used in case you have something like a space in the movie title like that, it's able to take care of it. But even without the backticks, this should be able to work just fine. So even if I was to remove the backticks that have been put here, it will still be able to work just fine because my columns don't have spaces. So just typing them even though the backticks should just be able to work fine. I'm just doing this to demonstrate for you that actually it will work, because if you had typed it by hand, probably you'd have typed it to look something like this. Okay. Then once you're done with the column names, then you put values. Then now here you will input a value corresponding to the column here. So movie title, I'll say Spider-Man. Then the director is Sam Raimi. That's my favorite, by the way. Sam Raimi. Then maybe the release year was, this was done in 2002, if I'm not wrong. There's a number. Then the rating, well, I don't know the rating, but I'll probably give it a 9.8 because I love it so much. Then the synopsis is maybe say a young man gets stung by a spider and gains superpowers. All right. Then after that, date added, I can simply say the current date and time. Don't worry about that. That's an internal function to get me the current date and time in my SQL. Of course, you can put the actual date here if you want to be a bit specific on the date. So I'll probably say this was added on 2024. This is mwezi wa sita tarehe tano or 5th. So 2024 June 5th. Then the movie status is released. Then, of course, deleted is 0 and added by is maybe 1, right? Something like that. So if I have this statement, I simply put a semicolon. You don't need to put a semicolon if it's just one statement. If you have multiple statements, then you need to terminate them with semicolon. So if I highlight that and I click on press play, you can see it is successful. It has been added. So if I come to my movie's title and open, I'll see I have Spider-Man here. So I have all these data done here. Let's add another one of my favorites movies. That was mm, uh, uh, Bruce Almighty. Bruce Almighty is another favorite of mine. I think it was Delroy Lindo, if I'm not wrong. I'm not sure. This was at 1998, probably. I'm not sure. Let me give it a 7.5. And maybe, yeah, I made a mistake here. Don't worry. I'll simply say a man blames God for all his misfortunes until God allows him to take his place for 7 days. So something like that. So, well, it is ready today, it's released and all that. So again, I can come here, highlight all this, and simply, by the way, if you're not seeing everything else, you can just create a new line. It's not a big deal. So long as you have not broken the syntax, it will be able to work just fine. So I'll click on press play. It's successful. Usually you just want to check down here if everything is successful. If you see any sort of errors, then you can come and fix them. So I come back to my movie's titles and I refresh here. I'll be able to see now I have that other movie. So that's how insert works. So insert uh, uh, the name of the table. Then now you provide the columns. Then you put values. Then you provide value for each of the columns that you have specified at the top here. That is data manipulation, and that's the first category, which is basically what we're talking about. Um, uh, the insert. So that's the insert statement. So besides the insert statement, of course, we're not going to have a lot of this. Well, maybe say about 30%. The other 70% we are going to write would probably be fetching data. We'll be fetching data a lot. Okay. So let's see how that works out. Okay. So I don't have a lot of movies, so I'll try my level best to be able to allow us to see how this works out. Now, to be able to get movies, we're going to use what we call the select statement. Select statement is going to be used to um, query data from the database. So to query data from the database, let's use the select statement. Now the select statement takes very many forms. It takes quite a lot of forms, but I'm going to focus on a few just to show us or just to get us around how to move with it. So the first thing, if I wanted to get data from the database, I'll simply say select. Now, when you say select, you have an option here. When you say star, it will mean it will select all the fields. Then you put space, then you put from, then you tell where you expect it to get the data from, which is movie titles, like that. Now, this is a very simple statement. What it will do is that it will get all the fields from movie title. So I select that, press play. You're going to see it has given me all the fields from my database without filtering anything. Okay, so it has basically given me all the data. It doesn't matter how many records that are there, it will basically give me all of them. You can also see that it has arranged the columns based on how they are appearing on the table itself. So the columns are exactly how they appear on the table design. Now, sometimes you might not want to return all the columns. Maybe say I want the movie ID, the title, the director, and maybe the synopsis. Okay. So if I want the ID, title, the ID, the title, the director, and probably maybe say the synopsis, what I will do here is I'll simply come down here and say select. Then I will specify the columns that I want in the order that I want. Let's say I want to start with the movie ID. So I'll say movie ID. Then I want to start with the synopsis. Then I'll say synopsis. Then I want to the title, then I say movie title. Then after the movie title, I want the release year. Then I want the rating, and probably and so on and so on. Maybe then say yeah. So let's say this. So you can see here now when I say select, I can be able to alter the order in which the columns would appear in my results. So of course, I have to come and say here from movie titles, like that. Well, around the semicolon because I'm going to be executing them one by one. So I run that. Release here. Looks like I don't have a column called release here. It's called real. Okay, I've misspelled the release here. So again, because I have spelled this release here, let me just alter it and correct it from here. You could still use the alter statement to achieve the same. Click that. So now you can see I have movie ID, I have synopsis, I have title, I have release, and I have rating. So when I say all or star, it means pick all the fields in the order in which they appear on the table design. But if I want to alter how the orders will look like and even choose just a few fields from the table, and then I'll be able to specify the columns that I want, then it will be able to give me just that. So these are the two simplest structures as far as SQL or rather select statement is concerned. So select, as I said, will enable us to be able to extract data as far as our database objects are concerned, and specifically tables or even views. Excellent. Now, because sometimes we don't want all the data, I might maybe say want to filter out data. So to filter out data, we're going to use a clause called where. So we're going to use the where clause. Clauses are basically parts of SQL structure which allow us to add functionality. So we have a where clause which allows us to be able to filter out data. So for example, let's say I wanted movies that were released in 2010. So I can still pick my query either like that. Then after from, down here, I'll add a where clause. Then with the where, now we deal with conditions. Now remember, we have different types of conditions in SQL, just like in any other programming language. We have we have we have operators which you can use. We also have uh, uh, yeah, actually most of them operators, because we're going to be dealing with arithmetic, we're going to be dealing with logical, we're going to be dealing with comparison. But here I'm going to be dealing with comparison for purposes of this particular example. So the comparison operator here is I want to check where the release year is 2010. So I'll simply say where release year equals 2010. So you can see this one is a comparison operand. So it will check if the release year is 2010, then it will return for me the results. Highlight that, run it, and you can see it only gives me one movie. I can say is not 2010, that is also allowed. So it will give me all the movies that were not released in 2010, which are these two, or I can even say greater than 2010, greater than or equal to 2010, or maybe say, let me say 2001. So if I say greater than or equal to 2001, I'll probably find these two, which is 2010 and 2002, and so forth and so forth. So when it comes to the comparison operators, you can be able to add them as much as possible. Then, of course, because you've learned programming, there's what you call uh, uh, logical operators. So I might want movies that were released before 2002, and probably maybe they have a rating of more than 4. So for if I want to compare those two values, I have two options. I have and or. So I can say and, maybe say the rating is greater than or equal to 5. Let me say 6. So it will give me movies that were released after 2001, and their rating is also more than 6. So if I run that, you'll see it gives me only one movie. So in the where clause, I can make this as complex as possible. Now, besides being able to search numbers, you can also search patterns. Okay, you can also search patterns. So, for example, I want a movie with the word man inside it. So instead of saying the release here, so I'll simply comment that out like that. That's how you comment in that's how you comment in MySQL. Otherwise, in SQL Server, you comment like this, like that. So this is SQL Server. This is MySQL. I don't know if this works in SQL Server, but I'm pretty sure this one does, because that's what I use most of the time. So if I wanted to check where the synopsis of the movie contains the word man, I can simply come here and say where. Now the synopsis, because we specify the title, then instead of using equal to sign, I'll use like. Now, like takes three parameters. Like takes a pattern, and you can actually use a regular expression for this. So, because it's a string, it has to be enclosed in brackets like that. Then it depends on how you want to search. If I want to search beginning with man, I'll simply say uh, percentage, then man. That means I don't care what it begins with, but it ends with man. I know I don't have any movie like that, so if I search that, I won't get anything. But I know I have the one that contains, so that begins with, then this means contains. So if I put the dollar sign on the left and on the right, it means so long as the synopsis contains, so long as the synopsis contains the word man, then simply output that for me. So around that, you can see now I have mm, man here, I have man here. Okay. Then if I wanted something like God, I'll simply say God. And by the way, it is case insensitive, so it will search whether you put it in lowercase or uppercase. If you want his, it will also give you that. So, but what if you want to end it with? If you want it to end it with, simply specify what you want it to start with. Then you put a percentage sign. So it means I don't care what it starts with. I don't it starts with his, and I don't care what it ends with. Okay. So in the other portion is I don't care what it starts with, but it ends with his. But of course, if you put it on both sides, it means it contains. So that's just how you'll be able to search. So that I said will be I don't care what it begins with, it ends with man. This other one is I don't care what it ends with, but it must begin with man. In this other scenario, it contains man. So that is how you would be able to search your database based on searching patterns and things like that. So that's the filter clause. As I said, this is just a primer. We're going to be using a lot of these statements as we move along within our databases so that we are able to see how to create effective queries for purposes of being able to uh, uh, do proper searches based on our movies database. Now, besides searching data, you might also want to be able to sort the data. So, to sort data, we'll use what we call the order by clause. So the order by clause will allow you to be able to sort data based on certain elements. Now, what you could do is, again, let's look at the movies that we have over here. And let's say we want to sort them out by the year that they were released. So for us to sort them by the year that they were released, we'll simply say order by. Then we specify the columns that we want to sort them by. So I want to sort by release year, like that. That will sort it out by release year. Now, by default, it sorts ascending. So you can say ascending, like that. That's the default. It will sort ascending. So whether you put ascending or not, that's the default. It will be able to allow you to sort it like that. So again, you can see sort 98, 2000, 2010. What if I wanted to sort it in a descending manner? Then I'll come and add here descending, like that. So that means it will be able to sort this movie in a descending manner. So now you can see it's 2010, 2002, and 1998. But you might also want to sort by more than one field. So I might sort by the release here. Then I want to sort by the rating. Okay, because I might have two movies that were released in the same year, but now I want the one that has the high rating to come at the top, for example. So I'll do that and I click on that. It allows me to sort by release year, and of course I only have one in 1998. Maybe I can add another one in 1998. uh, Maybe simply say exit once by Steven Seagal. 98, let me give it 9.5. And of course, well, I can leave that. uh, Simply run this. There's an error. Where is my error? It simply says a non-column release here. Oh, sorry, I should have renamed this one release here. Yeah, that's okay. So it's good to read the errors here so you are able to tell what the issue is. Sometimes when you write your queries you make mistakes. Do that, it's successful. Then I'm gonna come and highlight this and click it. So you see I have 298, but Bruce Almighty comes at less than 8 below because they are sorted in ascending manner. So it will sort by the year, then you sort by rating. But if you want the ratings to the one with the highest rating to come first, I'll say rating descending. So it means the one with the highest rating goes above. So you can play around with this as much as possible. Now, you could still be able to filter this. So maybe say I want movies released in 1998. So I can simply say here, I can add a where clause here. Release year is equals 1998. And I can make as a complex condition as I have here as possible. So I'm just trying to show us how we can be able to combine all these things, how we are able to combine all these things to be able to form very complex queries. All right. So that is how we would select data. That's how we would filter the data. That's how we'll be able to sort out the data based on our queries. I think I like the direction that this is taking because we are actually covering quite a bit of grounds. So next, I want us to look at functions. So we have functions in SQL, and functions are we are going to focus on inbuilt functions. We're going to build our own later on. So inbuilt functions are the functions that come packaged with SQL themselves, and they allow us to do certain things in the database. So we have two types of function. We have what we call scalar value functions. So the first category is scalar value functions, and in these functions, they work on specific data in a column. So you are working with, say, if I wanted to convert all the synopsis in all uppercase, I'll be working on each and every data in a specific column. That's what I mean by specific data in a column. So an example, we have quite a number of them. So let's begin with string functions. I'm not going to look at all of them, just going to look at a few so that you're able to see how that works out. So let's say, for example, we want to convert all the synopsis to uppercase. So what I'll do is I'll pick this query up here so that we don't have to type it all over again. I'll have this query. Let me just get some space down here like that. Then I'll paste this query. Now I want the synopsis to be uppercase. So here I can simply say upper. Upper is the function that converts everything to uppercase. Then there's the component of something called alias or aliases. Because when I do it like that and I run the query, it will give me those values. But now you can see I don't have a good title name at the top here. So you can see all the content has actually been changed to uppercase, but now I don't have a good column name. So for that, we're going to use what we call aliases. So you can say here as is not a must. You can actually put the alias name here as uh, uppercase synopsis. So as is not a must, but you can put it for readability purposes, but it is not mandatory. So I'll use without as. You can still see it works, uppercase synopsis, and even if I put as, it will still also be able to work just the same. So again, as I said, as might be uh, necessary or maybe not. Now, that is this. So upper is an example of a scalar function. As you can see, it works on each data within the query result set. So each data is computed is worked on independent of the rest. So on the specific column and row. Let's say we wanted to calculate how many characters the movie title contains. So here I can come and say, if I wanted to count how many characters the movie has, this is not standard SQL because it would how we call the function inside MySQL will be different from maybe say other implementations like SQL Server. But I mean, you can get around and see the slight differences that there are going to be. As I said, I wanted to be as standard as possible, but in some scenarios that might not be the case. So I can simply say here, car length is going to calculate for me how many characters are inside a particular string. So I want to calculate the movie title because maybe sometimes I want to know how many characters are there so that I'm able to display them correctly. So I say characters in title. So if I do that and I run this query again, you'll be able to see what did I miss out on? Oh, movie title. I missed an E here. Okay. So you can see it calculates for me. This one has 17, this one has 9, this one has 14, this one has 11, and so forth and so forth. We can have lowercase, we can have sentence case, I can even extract the first few characters of maybe say the movie title. Maybe say I want the first three characters of the movie title. I'll simply say left, then I'll say movie title, then I say the number of characters I want three. Then I'll say maybe I'll say this one is abbreviation. So maybe say the movies are abbreviated by the first three characters. If I do that and I click that, you can see they will say I have there, spy, blues, exit, and so on and so on. So these are what we are referring to as scalar value function, and there are quite many. If you do your research online, like I'll simply say SQL scalar functions, you'll probably get quite a number of them. Okay. You get, of course, I'm talking about user-defined ones. I'm talking about user-defined ones. Uh, you'll be able to see, well, this is a SQL server, not a big deal, inbuilt. scalar functions or built-in. So you can see we have mid, we have length, we have round, we have now, and we can go on and on and on. This you'll be able to get quite a bit of all these things if you do Google search. So there you'll be able to see how they are actually going to work. So those are scalar. That's scalar. Those are scalar value functions. So let's look at the other categories of functions, which are what you call aggregate aggregate functions. Aggregate functions. So aggregate functions, what they do is basically they take all the data inside your table or inside your query and they perform what we call aggregate values. For example, I want to sum, I want to count, I want to average, I want to find the maximum, I want to find the minimum, and so forth and so forth. So these are what we're referring to as aggregate functions. So they take all the data inside your table or inside your query, then they perform aggregate functions. So for example, let's say I want to count how many movies I have inside my database. So if I wanted to count how many movies I have in my database, I can simply say something like select, then I'll count. Now, the good thing with the count is that you can count anything. So I can actually even count all the fields. Okay. So it'll basically just count. And but what I want to do, let me say count movie ID. So I'll go to and I'll say movies total, total, like that. Then of course I have to say from my movies, my movie titles. So this one can compute for me. You can see I have 4 movies in my database. Actually, if I open my database, you'll see they are. Let me just refresh this. They're actually for 1, 2, 3, and 4. So this is an example of an count is an example of an aggregate function. So count will take any data type. Now for count, maximum and minimum, they'll be able to work on any type of data. But things like sum and average and standard deviation and so forth, you have to provide number data type. So, for example, if I want to know the average year of release as far as my movies are concerned, I can come here and say select uh, average. Then what do I want to average? I want to average the release year from my movies database or movie titles. That will average for me what is the year of release. I can see it is 2002. Why 2002? Because I'll take um, 2010, 202, 98, and 98, add all these things together, then divide by 1, 2, 3, 4. Then that gives me an average of 2002. Okay? So that is how uh, uh, um, we work with aggregate function. I might want to know the sum rating. What is the total rating for all the movies? By the way, the average rating would work best. So if I wanted to work with average, I can say average rating. What is the average rating of all the movies in my database? They are at 8. Okay. Now, if I wanted to sum the average, so I'll simply say something like select, say sum. Then I can say, what do I want to sum? I want to sum the rating. So take all the ratings and add them together from my movie titles. And again, I can add a where clause here, then and all those other things. So I'm only focusing on the specific operation, which is the aggregate function. But of course, you can do a where clause, you can do an order by clause, and so forth and so forth. So if I do that, so total rating is 32, which means if I take 5.2 plus 9 plus 1.5 plus 9.5, that should give me a total of 32. And you can do that. 9 plus 9 is 18. 7 plus 5 is 12. 18 plus 12 is actually 30. Then if you add these 4 points together, they should total to 2. So that should give me 32. So we have quite a bit of aggregate functions. We're going to look at them. I'm just focusing on how we are able to use them. We have something like maximum and minimum. So maximum will basically get, if I wanted to know the oldest movie in my database, I can simply say select maximum is the most recent. Then I'll simply say release here. from movie titles. Movie title rather. Titles, yeah. One title. So the most recent movie is 2010. If I want the oldest movie, I'll say min. You'll get me there. Oldest movie, which is 1998. So you can be able to see now with these aggregate functions, they are able to take all the data inside my database and allow me to be able to work with that data depending on how I want to work on it. And by the way, you can be able to combine all these things together. So I can say sum, I can say rating, I can say this and this. So it basically will allow me to be able to work together. All right. So then, besides the aggregate function, we also have grouping functions. So, for example, I want to know how many movies were released in a particular year. So, how many movies are in 2010, how many are in 2002, how many are in 1998, and so forth and so forth. So, for that, we're going to use grouping functions. So, for grouping function, we have group by clause. So, we're going to use the group by clause. This clause will allow me to be able to um, this clause will allow me to be able to group elements. So, for example, let me say I want to pick a year and I want to count how many movies were in that particular year. So, I'll simply say select, select. Then I'll say, um, what do we call the? It's called release here. Select release here. Then I want to count how many movies were released in that year, isn't it? So I'll say count, and I can count movie ID. I can count anything as movies released in that particular year. Then I come to from, then I say my movie titles. Now, this would not work if I did it like that. Actually, in most implementations of the RDBMSs, it won't work. I know in MySQL it would work, it will give me the wrong value. So it tells me in 2010 we have four movies. But if I come back to my titles, in 2010 I only have one movie, but in total I have four movies. So it has done it wrongly. So why it has done it wrongly is because I have not grouped. So what I need to do is I need to tell it group by, then I tell it what I wanted to group by, which is the release year. So it means take the release year, then group that and count all the movies that were released on that particular year, and continue like that as you move around all the columns. So if I do that, you'll see 1998 we have two, 2002 we have one, and 2010 we have one. So if I come back here, 1998 we have two, 2002 we have one, and 2010 we have one. So the group by here now allows me to be able to group it nicely. Now, what would happen if I wanted to check only only uh, uh, only years that have more than one movie released? I know you're going to try to say something like where here, uh, and you say count movie ID is greater than one. This will not be able to work out. That will not be able to work out because you can't use this aggregate function in a where clause. But that's what you want to do. So if you wanted to filter out an aggregated column, instead of saying where, you're going to say down here after you group by, you're going to use the having clause. So that having clause now allows you to be able to filter what was actually aggregated at the top here. So that should now give me one. So you can see I have one. So if I don't have this having, I'd have all of them. But if I add the having where I have more than two movies released in that particular year, then I'll put the having clause, and that allows me to be able to filter what I have grouped. That's very important because we are going to be applying that over and over again. So that's quite a mouthful, and it's a primer. As I say, we're just trying to learn how SQL works, how we can be able to take advantage of it. And as you can see, when it comes to fetching data, that is the largest amount of thing we're going to do. So the other thing that I am yet to look at is joining tables, and this is very important because we are using what we call a relational database, and as such, all our data is going to be stored in different tables. So let me just go back and create my users table again. Do I have my users table over here? I think I have it here. Let me create my users table again, like that. Once I create it, let me add a user. So if I refresh this, I have my users table back. So let me create a user in my table. So I'll say insert into users. I'll insert my values down here. I like writing it like that so that I just come and now fill in the details. So user ID, well, I want it to be auto increment, so alter this. We don't have enough time to start writing alter statements, so I'll just use the GUI for purposes of that. So I want to add my username, first name, comma, first name, and last name. So username here I'll say is admin, first name is system, and last name is administrator. Something like that, right? Then of course I'll highlight that, I'll click on that. It will add that particular user. So inside my movie, if you come back to this table, you'll see that the user has been given ID number one. So I'll come to my movie's title over here. Well, let me add another user. Let me say support. Then let me call these user support. So that creates another user. Now, inside my movie titles, I want them to be created by different users. So I want this one to be created by admin, this one to be created by user, and this one also to be created by user, right? So we have different users creating different movies. So now, let's say, for example, I wanted to know all the movie titles, similar to what we had up here, up here. And we wanted to know who added the movie. So for now, we only have the details of the movies, but we want to be able to know who added them, right? So who added them? If I come here and say added by, that will tell me who added them, but it's going to give me just a number. What I want is actually the name of the person who added. So that means we have to use what we call joins. Okay, and by the way, it's possible that you might also have a movie that has not been added by somebody. So let me say this one has not been added by somebody. So let me put it now here, assuming that data was null, because I want us to explore the different categories of joins that are available. So joins allow us to combine tables into a single results. It allows us to combine tables to combine, not combine, combine tables into a single result set. So that way, we are able to fetch data from multiple tables, put it together as one query, and remove the complexity of how that works out. And that is the basis of how we're going to create our views for purposes of end users absorbing that information. So, as I said, this is just a primer on what you need to know in order to be able to effectively be able to manage our database objects and queries and views and stored procedures and functions and triggers and almost everything else as far as our database objects are concerned. So let's look at joins. Now we have different types of joins. So the first one I'll use is what we call an equi-join or an inner join. So in an inner join, basically it means that I have two tables. I will make sure that data matches both the tables, right? So let's say, for example, I want added by, but I want to show the name of the person who added it here. So here, what I'm going to do, I'm going to put the other columns from the other table. Now, what's important is you have to make sure that columns that are on both tables have a prefix. And we had talked about aliases before up here. So whenever you have a column that comes from two tables but it is named the same, then you have to add an alias to it. I'll show us in a short while what that looks like. But for now, all our columns are unique, so that's not necessarily a big deal. So I'll come here and say I want also first name, and I also want last name. Okay. Now, from movie titles, that is the first table. The other table, you can put a comma and put the other table, which is users. Then you can use a where clause and say, now here I have to use aliases because I'll set this one as M and users as U so that I avoid doing things like this. Now, as it is, I would be forced to write this query like this. If I didn't use aliases, I would say movie titles dot added by is equals to users dot user ID. I'll be forced to do that. So I'm picking data from the first table and the second table where the movie title dot added by is equals to users dot user ID. That makes a lot of sense because if I come from movie cycle title, I have ID1, ID2, and ID2. Then when I come to my users table, I have ID1 and of course I also have ID2 here and ID2. So I'm just comparing those two columns, this added by here and this user ID here inside my query to form uh, my inner join. So this would work, and this is standard. And as you can see, it will give me the movies, but if you notice, it has only given me 3 movies because I have one movie that does not have a user who created it. So it means that those two records don't match. So that particular one set of one movie is actually omitted from this query result set. So that's what inner joins do. Now, you can write it this way, that would work, but I don't writing it this way. So again, you can put an alias here as M and here as U. Then you replace these long titles with M and U. Makes it much easier to read like that. Okay, so when I use an alias, I simply add the alias here as opposed to now the full table name. An alias is another name of, so that should it should see work just fine as you can see there. So that's one way of writing it. The other way of writing it is using the inner join statement itself. So I'll pick up to here, or rather I'll just pick the whole of it. So the syntax will be slightly different. So I'll say that, then instead of putting a comma, I'll put inner join that. Then instead of where, I'll say on. So that would work the same as the one that's at the top. So I'll put that. You can see it works exactly the same way. So I like this lower option or lower version, though this one is much more easier to write, especially if you have multiple tables. So you just put commas and you list your tables with the aliases, and then down here you just compare where the equijoins are. Actually, this is inner or equijoin, where they are equal, then it should be able to work just fine. So as you have seen, in this particular case, in now it is not going to be able to tell us the movies that don't have users who add them. So I have system administrator, by the way. We can concatenate this one. So we have concat as a scalar function that allows us to concatenate multiple fields together, or to concatenate, that's the correct word. So put a comma, put a space like that. Then you say as added by name. We're going to be using a lot of this. That's why I'm taking my time to show us how to go about them. So I want you to be comfortable with them upfront. So again, if I do that, it should be able to add it together with a space. And as you can see, even the first one should just be able to run just fine. So that is an equijoin. What if I wanted to return all the fields, whether they are matching or not? So I want to show also this other movie called Exit Wounds, but it does not have a user who added it. So it's an orphaned record, so to speak. So for that regard, we'll use what we call an outer join. Outer join. Now, outer joins, what I'll do is I'll just pick this particular statement here. So instead of inner, by the way, I can omit inner and just say join. That's the default. When I just say join, it will still work fine as an inner join. So whether I put inner or join, just works fine. But I like being a little bit explicit, so that's why I put inner. But just the word join will actually mean it's an actual inner join. Now, for an outer join, I'll simply say outer join. So get me all the movies, then get me matching records on users. So all movies must be returned. So the table on this other side, all the records must be returned for the tables on this side. Then matching records from the table on this side. So it means even if a movie does not have a user, then it should be able to show. So when I run that and I execute that, what did I miss out on? Yeah, you should specify the direction because I want the records from the left table. So I'll say left outer join. So all the columns on the left. So that means left outer join. Sorry, I forgot that. And as you can see, it will be able to give me all the all the records, including the ones that don't have users who created them. Now, if you want to write a shorthand for this, I don't know if it's going to work in MySQL, but in SQL Server it would work. So let me just, it's here. So what I will do is, because I want all the records for the table on the right, I'll put a star here, like that. So in SQL Server, this would work. In MySQL, I doubt if it would work. Now, in MySQL, it won't work. Let me just check if they have a shorthand for it because I've actually never tried the shorthand. MySQL outer join shorthand. Um, I don't know if they have a shorthand. Let me just see. As again, I want it to be practical. So shorthand, do we have it? Now they only have left. I don't think there's a shorthand. I'm not sure if there's a shorthand, but in SQL Server, there is actually that shorthand that I've just shown you. In this other one, I'm not sure there is a shorthand on the same. Okay, so again, it will depend on which implementation of the database you are using. So that's joins, and we can join more than one table. You can join three tables, four tables, five tables, even 10 tables. Because if you are looking at our movie database, you realize that we have quite a bit of uh, uh, tables that are related to the movie titles. We have the directors, we have the production companies, we have the ratings, we have the cast, and all sorts of things. So we have the media and all these kind of things. So when I want to get a movie with all its aspects, it means that I'm going to be able to join multiple sets of tables to come up with one query result set, which I can now be able to give to the end user in terms of a report or a search result or something like that. So I want you to practice this because next I'm going to use exactly what you've learned here to develop things called stored procedure. Now, part of what you need to do is we have spoken about DDL and I've talked about the alter statement. And in particular case, I've added a check constraint. So we didn't add check constraints last time we created a database. So maybe you can take this time to add the check constraints for the fields that require check constraints. For example, things like gender is either male or female. Release here is either release, upcoming, or cancelled. Things like movie status. Is it available or is it or is it banned in this particular country, and so forth and so forth. So you should go ahead and add all the check constraints that are necessary as far as your database fields are concerned. So I think I'll take a break at that for today. I will want you to allow you to practice all this, then we can be able to carry on at within our next lesson. Now, for most people, I've not seen your assignments. I have marked for those who provided them. I'm still looking at others. I know there are quite a few that I've not looked at. I'll look at them today. But kindly make sure that you just cancel the request you had sent me before. I think my Gmail account was full. So you should just cancel that particular request and add it afresh. I think I should be able to get the notification and I'll be able to accept being a collaborator. Then I can be able to be marking your work as we go along. So it's going to be a continuous process as we move along with this class. So I'll take a break at that and I'll allow you to practice this. Then we can meet during the next class. Thank you very much and enjoy the rest of your day.